In this video, we will talk about section 8.8, probability, mean, and median. So we first review the definition of probability. Probability that a value is between A and B is equal to fraction of population between values A and B is equal to the integral of pt, t from A to B. So now let's look at an example. Suppose you want to analyze the fishing industry in a small town. Each day, the boats bring back at least 2 tons of fish and never more than 8 tons. The density function describing the daily catch is given in the picture below, with the probability that the catch will be between 5 and 7 tons. So we want to find the probability that the catch will be between 5 and 7 tons. According to a definition, the probability between 5 and 7 is given by this definite integral of pt, t from 5 to 7. Pt is the density function. So we are given the density function by this picture. So from this picture, we see that px is equal to 0.04x, x between 2 and 6. Px is negative 0.06 x plus 0.6 when x is greater than 6, less than or equal to 8. So the probability catch is between 5 and 7 times is equal to the integral from 5 to 7 px dx. So from 5 to 7. So this is equal to from 5 from the picture we see from 5 to 7. Px is a piecewise different function. 5 to 6 is this line. 5 to 6 to 7 this one. So we divide the integral into 2 parts. 5 to 6 px dx, then plus 6 to 7 px dx. This is when x is between 5 and 6, px is 0.04 x dx, then plus 6 to 7, then px is negative 0.06 x plus 0.6 dx. So evaluate those integrals we got. This is equal to 0.43. You can check it. Next, we look at the median. So first, introduce the definition. A median of a quantity x distributed through a population is a value t such that half the population has values of x less than or equal to t, and half the population has values of x greater than or equal to t. Thus, a median t satisfies the integral from negative infinity to t px dx is half, where p is the density function. In other words, half the area under the graph of p lies to the left of t. Physically, one can think of the median as the place to cut the density so that half the total area lies on each side of the cut. So this is the graph of the density function. So median t is here. That this is half the area, half the area. So next, we look at an example. Find the median. Median age in the US in 2012 using the age density function given by PT is 0.013, T greater than 60, and 0.0358 minus T between 60 and this number. So we wanted to find the median age. That means we want to find the value of t such that this integral holds. So we want to find the t such that negative infinity to t pt dt is equal to 0.5. So since t starts from 0, right, this integral is equal to 0 to t pt dt is 0.5. So we know this density function has this kind of graph. So this PT is a constant up to the age 60. Then it's a line. So here is line 3.85. So PT is 0.013. So how PT is this number 0.013 up to age 60. So we have its median is equal to t is equal to half divided by 0.013. So this is approximately equal to 38 38.5 years. This is 38.5. So this is, the area is 0.5. So this is about the median. Next we introduce the definition of the mean. If a quantity has density function px in value of the quantity is equal to, from negative infinity to infinity, x px dx. So in fact, one can think of the mean as the place to put a full term so that the distribution balances. When put full term here, the distribution balances here, the mean is here. It's the balance point. So we look at an example. Find the mean age of the population. Using the density function. Pt is 0 for t less than 0, 0.013 t, and for t greater than 60, Pt is 0 for t greater than 93.85. So using the formula, we compute mean age is equal to, from 0 to 100, pt dt. So this is from 0 to 60 t pt dt plus 60 to 100 t pt dt. From 0 to 60, it's a constant. Pt is a constant density function. Plus from 60 to 93.85 over 93.85, the pt is 0. So it's t times pt. dt. So this is equal antiderivative then minus 1/3 t cubed, t from 60 to 93.85. So this is calculate those values. We get this is approximately equal 39.3 years. If we show the mean on the graph, it looks like this. It's a T0 PT. PT is 0 from 0. PT is the constant. 0.013 from 0 to 60. Then it's a line from 60 to 93.85. So get the mean is 39.3. This is the mean. It's also the balance point.